Well, greetings, Mr. Kolazar's class. We're going to jump back in and do a little bit of math review. So that's going to be an interesting change here. It is part of Chapter 2 in the textbook as we're going, so it is going to be a little bit of jump back, but now it's going to be an important part of our class coming up for the rest of this year. So that's why we're going to review and use it now, because it's going to be really used a lot in the upcoming chapters 10 and 11 especially, but then as we're going for the rest of the year also we're going to be using this idea, and so we just want to have everybody on the same page. Now it's going to be important that we keep on track with our videos, using that information to help us out solving our problems in class. And so it's going to be really broken into 3 parts. So part 1 is going to be our significant figures, part 2 scientific notation, and part 3 is going to be our dimensional analysis, and we're going to see all of this coming up a bunch. Key is, don't lose this. Make sure your name is on here so that you have this as a reference packet in the future. Now we're going to start in on a lot of different measurements, and so machines or instruments can take measurements. Now like a balance for weighing or a graduated cylinder, are certain tools used to help us make measurements. So all of these, no instrument can read an infinite number of decimal places. So if you were to measure something out like 7.34 grams might be measured, but no instrument can say like 7.3415628. Eventually that machine has to stop on how accurate it can actually be. So as we're going, no instrument can read an infinite number or measure an infinite number of places. We're going to hear sig figs. Significant figures are going to be a lot of what we'll talk about. Sig figs are going to be those digits reported for any measurement. So as we're going, sig figs are going to be the measurement of the numbers that we're going to be reporting on during a problem or during any lab work that we do. There are going to be a set of rules which we follow to who is significant, and later on you'll get an extra handout to help us out there. It's not in your gold packet, it's not there, it'll be an extra piece that's given to us. So an example of a measurement, let's say this is a graduated cylinder and that we're actually looking at making a measurement on it. Our first question is, what is the smallest increment on the graduated cylinder? This is all the way back from chapter 2 at the beginning when we were making measurements. And we look here and it goes between 5 down to 4 milliliters. So each of these, 4.1, 4.2, would be a tenth of a millimeter marking. Now what we're going to do is to remember back, if we're somewhere between 4.2, 4.1, or wherever we're at on the measuring scale, we're always going to estimate one spot further than our measurement says, so we can be a little bit more accurate even though it's not exactly precise. So as we're looking, our meniscus line, so we're right about 4.1, 4.2, 4.3, 4.4. So right now, tenth of a millimeter is our smallest measurement. So we're at about 4.4. Now we're always going to go one decimal further with estimating. So we're always going to estimate one extra decimal or one extra number. So 4.4, and we're right at that almost 0. It could be 4.40 milliliters. You know, some people might say 4.41 milliliters would be acceptable. 4.39 maybe even. But it should be pretty close to about, you know, kind of a plus or minus about 2 on whatever your scale you're estimating or approximating that last spot to be. So that's just a little review from back in chapter 2 at the beginning of the year. So back to our significant figures. Significant figures. First off, if we are counting numbers, so numbers of anything, example would be if you have 10 fingers. 10 fingers, anything counting has an infinite significant figure. So 10 fingers would mean that you have 10.000000, how many ever zeros you want to put? Fingers. So there's an infinite number of sig figs when it comes to counting. It's just exactly how many you have. There's no actual measurements taking place there. Now for any other measurements that we're going to look at, first rule, if it's a digit between 1 and 9, all of those are significant. So they're always significant, the digits are, 1 through 9. So we have 13.1, 1, 2, 3 digits are being shown, so it has 3 significant figures. Or 1, 2, 3, 12,345 centimeters, 5 significant digits are shown. Now the zeros, those are the ones we're going to be worrying about. There are going to be a couple different sets. We'll have our trailing zeros, our leading zeros, and our sandwiched zeros are going to be all looked at. Now let's just change this from Dalmatians to pounds. Dalmatians won't work. Now sandwich zeros mean if we have 101, the zero that's in the middle is sandwiched between two numbers. So a sandwich zero says we have 3 significant digits. So a sandwich zero are always significant. So 1.003, 1, 2, 3, 4. Both zeros are significant in the measurement since they're sandwiched, meaning they're in between two numbers or 2 digits. The following are sometimes significant. So now if we look at trailing zeros, if there is a decimal point, then we say yes to it. If there is a decimal point, then that's a yes. So 2.00 grams per cubic centimeter has 2 significant figures. If we had a number like 2, there'd just be 1 significant figure. Or 2.0 would have 2 significant figures. How many ever decimals we have if there's a decimal point? No, if there is no decimal point. If something's 32,000 degrees, only the 2 digits that are given are significant. If there's no decimal point, then we don't have a significant digit. If we did have, say, 32,000 and then a decimal point, that would equal 5 sig figs. But with no decimal point, then we just have our 2 sig figs. Leading zeros are never significant. So zeros before any number are never significant. So no, no, and no. So we only have our 3 significant figures here. Leading zeros, nope, nope, nope. Digit, yes, and trailing zeros, yes. So 3 significant figures are reported here. These 2 zeros afterwards are showing that our measurement is more precise or significant there as we're going. So let's give you a minute. Go ahead, hit pause. I would like you to work through these problems, A through H. After you're done, go ahead and unpause and check over to see how your answers turned out. So I know that you've went through the problems. Our first one, 1, 2 digits. Our measurement, so we have 2 significant figures. For B, 2 digits, leading zeros are no, so we have 2 significant figures. 102, we have a sandwich. 0, so 3 significant figures, all are significant. 5 cars. Make sure we didn't put 1 down here. Counting is always infinite number of significant figures. 120 seconds. 2. Reason why? No decimal. 1.20. Since there is a decimal trailing 0, all 3 are significant from our rule. Leading zeros are not significant. Digits and sandwich zeros are. In 120 lamps, again, if you were to have, that's a lot of lamps. If you had 120, all of those digits are significant as we're going, so we have an infinite number. You could say it's 120 or 120.0000000 lamps as we're going. So all of those figures are significant. Now, an answer cannot be more precise than its own measurements to begin out. So the measurements you take down are as precise as your answer can be. Your final answer should not have more significant figures than your original data. So if you've ever taken, say, 22 divided by 7, you get some number that equals like around 3.14 something something something, you know, as you're going 3.14 2857143, etc. Now, our data started out with this numbers. As we're going, we can only be as precise or significant as our original data. So as we're going, our numbers further along aren't going to really matter. That's what we're going to start in on next section.